Welcome back, everyone. We're going to be solving LeetCode 230, kth smallest element in a BST. So we're given the root of a binary search tree and an integer k. We need to return the kth smallest value, 1 indexed, of all of the values of the nodes in the tree. So example 1, right? We're given this tree of 3, 1, 4, and 2 with a value of k. So the first smallest element in the tree that we come across is going to be 1, right? So let's take a look at example 2, because we have an output of 3 for example 2, we have a k of 3, and 3 is the third smallest value in the tree, right? It goes 1, 2, and then 3. So how can we solve this? Well, we can use depth first search to solve this, and what we're going to do is we'll traverse the tree, but we're going to traverse the tree doing an in-order traversal. When we do an in-order traversal, we'll start here, right? We'll start at the leftmost subtree, and we'll keep going up. So doing an in-order traversal on example 2, we'll get 1, 2, 3, 4, 5, and then 6. So now that we know how to do the in-order traversal, right? I just told you how the nodes are going to pan out in this traversal. We can just take k, right? And every time we move up, we'll just subtract 1 from k. And then whenever k is equal to 1, that means we've found the node that we're looking for, and we can just return the value. So let's get our depth first search set up. We know it uses a stack, so we'll say stack is equal to an array. On this array is going to be the root and a visited status of false initially. And we only have to return the node value, so we don't need an output array. So we'll say, while the length of our stack is not equal to 0, what are we going to do? We're going to grab the node and the visited status with stack.pop. Now, we're going to check if our node is not none. What are we going to do? We're also going to check if the visited status is true. So if visited is true, then we want to do something. What do we want to do? Well, we want to check to see if k is equal to 1. So we'll say if k is equal to 1. If it is, then we can return the node. So we can say return node.val. Otherwise, what are we going to do? It means we're not at the node, so we have to decrement k by 1, right? So we'll say k minus equals 1. Okay, now, if we have not visited this node, what are we going to do? We'll say else, and we will say if node.right is not none, right? We have to check the children. We'll do a stack.append the node.right along with a visited status of false initially. Now, here we can append the node and visited status of our original working node, right? This is going to be in order, so in order has to go before we do the left side. So we'll say stack.append the current working node, and we will change the visited status to true. Now we can check the left child. So if node.left is not none, we are going to say stack.append node.left along with a visited status of false. So that is the entire code for this problem. So let's run this. Perfect. We passed both test cases, so we'll submit. Awesome, and it does run. So time and space complexity. Time complexity is going to be O of n for this problem, and the space complexity is also going to be O of n. Right, we have to traverse at most all of the nodes in the tree, and our stack can grow to the height of our tree. All right, that'll do it for LeetCode 230.